For the people online, I emailed you this last night. I emailed everyone in the class this last night. Okay? Now, this here is pretty much a step-by-step guide of how to go through everything. Okay? I organized it where, like, here's binomial theorem, Pascal's triangle. It kind of works its way across. Here's binomial probability, works its way across. Normal approximation works its way across, has the steps all written out. Even has how to find the high and low value, right? Hypergeometric probability is all the way across. This is really good to learn from. I cannot give it to you, cannot have this exact copy for the test because it's pretty much like a cheat sheet, right? It's a Mr. Magoo.
What's wrong with Mr. Magoo?
Okay.
It's like an almost, it's like a halfway.
Like here, it goes step 1, find the mean. Step 2, standard deviation. Step 3, find the z-score. Step 4, interpret results, right? It walks you through everything. Thank you. So this will help you as you review today. But I can't give it to you. This is what the other class has for a review sheet. Looks like this, right? Could you imagine the bows flying if Yark came in here and saw our like that whole sheet and right? So so you have two options. Okay? You have two options of what to do for your formula sheet. Okay? Option 1 is tell me to print this out for you. Okay? Option 2 is I gave you, and I'll send to the online group in a minute, I gave you a blank one, okay, for you to fill out within there using the formulas. You could add, I don't mind if you add the names of the formulas on top, in all honesty, but you can't have it as written out. Like you can't have, like for here, the meaning of every letter. You're going to have to memorize that, right? Oh man, I got to do work. But you're going to have to memorize what those letters mean. But if I were you, I might put them horizontally, like group everything horizontally together, right? So if you know it's a hypergeometric, you could put the hypergeometrics beside each other, correct? So you know when I have a hypergeometric, this is my probability formula. This here is my expected value formula. When I have a binomial probability, here's my formula. Here's my expected value formula for that, right? If you guys want to organize it like that on your sheet, like going sideways, feel free. You just can't have all the examples. Like here, it's pretty much got the answers here for you. So you can't take this. I'd have to take a look at that before. You'd show me today. No, like because it kind of has to match. Like you want to be the same, right? When you go into a university test, right? They're going to just hand you a formula sheet, right? I know what you mean. But if you memorize the acronym and then once I give you the test, you write down the acronym, I can't stop you from doing that. Does that make sense? Okay. Does that make sense, everyone? So it's there for you to work from. And realistically, once you start using the formulas, you'll know what what it means. But you just have to practice and use it and practice and use it in order to fully understand it. Yes, Callum? No, I want you to do it by itself. It's super easy. Like 3 questions. We're going to be going over questions just like it on this, right? You can use this formula sheet for that, right? I expect everyone, my expectation is we come back from lunch, you do it, then we'll take it up before you leave today. It's 3 questions. It should take you 22 minutes max, okay? I like to pick odd numbers like that. What, like not a, whatever. But when you use the microwave, what numbers do you usually press in?
30.
Yeah, I never press 30. I'll press 31 or 38 or 32 or 29. I know, but I don't like writing the, I I don't like putting like on the 15s or the 10s.
I'm like that with volume.
So.
I was like 56.
Okay, so let's get out the sheet from yesterday. And let's get cracking here. Did the Star Wars people enjoy today's meme?
I did. I'm not gonna lie. It's better than a lot of yours. Better than some of the recent ones. One of the top few ones. Some of the recent ones haven't been hit too hard.
All right, here we go. 20. I almost say candles. 20 M&M candies in a dish. 8 are brown, 3 red, 5 green, 4 yellow. 2 candies are picked at random. Okay? What's the probability of getting both red? So here's our 3 choices. We're going to have 3 choices here. We are going to have binomial. We're going to have, what's the other one? The binomial approximation, right? Normal approximation. And we're going to have hypergeometric. So here's your thought process here. Binomial. What's the first 2 letters mean? 2. Right? 2 options. Right? Options are either like right or wrong. Okay? Like sometimes it may be like multiple options, but there's only one right answer, one wrong answer as you go through. Okay? So that's kind of how you look first of all, right? Is it binomial? Right? It's going to have one of 2 options. Okay? If it's a normal approximation, it'll tell you to approximate the results, or you have a wide range, correct? You have like over 20, and there's tons of calculations you can do. And hyper is the S word, not the 4-letter S word, but the longer S word. What's that S word again? Sample. So when you pick things, right, that is a sample. Right? You're sampling out of the dish. The other thing you'll notice on your formula sheet there is with binomial, I wrote like the 3 times it happens. Number 3 statement there says the replications are independent. Okay? So that means like you replace every draw you make will be the exact same probability. But if I take 1 red out of the dish, is my probability of getting another red out the second time the same probability? If I take how many reds are in there? Once I take red, set it over to here. When I go, okay. So which one are we using here? Binormal or hyper? Hyper. Good. Perfect. Now, oops. How do I list it on there? Where's my thing? A, N, R, and X. Okay. What's my A value? What's the item of interest here? No. My item of interest is the red, right? So item of interest is 3. Okay. What's my N number? 20. That's my sample size, right? What's my R number? What's R mean? Oh, sorry. Number of items. What's my sample size? How many am I taking out? 2. 2 candies. And X is, yep, 2. That is the number of items of interest you want from A. Right? I want both my samples to be red. So of the A group, how many do I need? 2. Okay? Then I go with my formula here. Now you can say P of red, right? So A over X, which is 3 choose 2. Now you don't have to write it like that. You could write like 3 choose 2 if you really want to. I'm not going to mark you wrong there. Right? Then I have N minus A. So that's 17. And R minus A, which is 0. Over my total options, which is 20 over 2. Now, logic tells you here, oh, it's done right. Logic tells you here, this is your like wanted group, correct? And this is everything else to fulfill that. And to divide it by all options. Like if you just want to memorize the formula as such. All right, so you guys figure out the answer there? Make sure you can use a calculator to find it. Where's your? You need to go buy a calculator tonight. Does Floyd have one? You guys need to find a calculator you like and know how to use it. Therefore, when you go off to like university and take stats, like it's your baby.
I know how to use it.
You're not buying my used calculator I bought off Kijiji. But then I had to buy new batteries for it. So it costs as much as a new calculator. So it wasn't a win-win. All right, what'd you guys get? 0.016?
Yep, you're right.
Okay. I'll make a note of how many decimal places I want. Right? 3 is probably a good number. Okay. What's the expected number of candies if you pull 2? Now what formula are we going to use for that? For which one? There's 3 of them. Yeah. So the expected value of red, expected number of red is RA over N, which equals 2 times 3 divided by 20. How do we feel about this? Good?
All you need to know is what formula to use something under.
Yep. But the tough thing is identifying which formula sometimes, right?
Yeah.
Am I good to go for the next one? All right. Gotta figure out who am I limiting. Yep. No. No, because that's R is your sample size, right? So if we pulled, like we could have had a situation where we pulled 10 M&Ms out, and we want 2 red in that. Okay? So if I pulled 10 out, my R would change to 10. My X would still be 2 because I want 2 reds. Does that make sense? Yeah.
Is your expected number supposed to be in fraction, or is it okay if it is
Either or. Fraction is just a number, right? Okay. So, a candy dish contains 100 jelly beans and 80 gumdrops. 50 candies are picked at random. What's the probability 35 of the 50 are gumdrops? Do we have binomial? Fire, Dante.
Binomial. Right? Oh, God, it's picked. Sample.
Right? It's a sample there. Okay. If you said what's the expected probability, then it would be binomial. Does that make sense? Because nothing's been. It'll be interesting to see if we did the same calculation, whether it would work the same way. Okay? So, we're hyper again, correct?
Yep.
So, A, N, R, and X. I almost want you guys to write it down first before I give it to you. How are we doing online with this, okay? Oh. All right. Callum, you want to take a shot at this?
Yeah. Should I just look them all off or like?
Probably at 35, 50
Okay.
are gumdrops. Okay.
80, 100, 50.
Well, slow down. 80.
Yep. 100.
I disagree with you there.
Is N not number trial? It's 50.
180.
100.
There's 100 jelly beans and 80 gumdrops.
Yeah. Okay.
Okay. And what was your sample size?
50. Yep.
50 and
35.
35. Very good. So probability of gum equals 35, so gumdrops equals 35 is, now if I were to logic this out, 80 over 35, because that's how much of that population I want, right? Then if the other population is 100 over 15. Is my formula correct? A over X and 180 minus 80, yeah. So if you think about it like that, how much of the, like what's my given item, what's my item of interest probability? I have 80 total, I have to pick 35 out of it. Then how much do I have left over? I have 100 left over, I need 15 out of those. Does that make sense in your head? Then my total would be 180 over 50, because that's all my options. All right, try it again. Did you press equal? Go 80 choose 35 times 100 choose 15 equals? Getting an error? Pardon? Let me see.
Oh, that's very small number.
80 choose 35 times 100 choose negative 5. 1, 2, 3, 4. I thought it's 4. Oops. Yeah. 15 equals divided by 180 choose 50. I wonder why we're all getting errors. But someone got an answer? You get an error, I get an error. You got it? Same answer I got? 1 point. Okay. I wonder why that's happening. 80 choose 35 times 100 choose 15. 1.4 to the 40 divided by 150, choose 50, 180. Yeah, okay. The formula is right. I will make sure all test questions don't get an error. Who got an error on the calculator by hand? Okay. Sophie, did you get an error or not?
I did.
You didn't? Nope. Okay. Maybe it's because I bought my calculator off Kijiji. All right, next one. But the formula is there. That work. Like, if you have that, you're good to go. I'll make sure I'll run it all through my calculator before the test comes out.
Wait, what calculator are you using?
Sharp.
I'm using one that you
Yeah. It worked for you? Okay, Adriana. Some people got it to work, some people didn't. Yeah, it might be -5. I have -4 on my answer sheet, but everyone got -5. Okay. Adriana, did you get 10 to the -5 or 10 to the -4? Did you have an extra 0 in here in your answer?
Where is this from on the
-4? Okay.
No, it's different. Is it not on here?
Which one?
No, it is on there.
Okay, here we go. A student randomly guesses 10 multiple choice questions. Each question has 4 possible answers, with only one being correct. And each is independent from the other. Okay? So we have multiple choice question. Which one do we have? What do we think here? Tell me why you think it's binomial.
Because there's only one correct answer and there's only one answer, so it's right or wrong.
So right or wrong, good. So you have, it's binomial.
There's only 2 possible events.
Good.
Right or wrong.
Yep. So if we look at our binomial formula, where do I put that? With that being said, there should be no fraction in the binomial formula. You see that fraction there where it says n over p? N over k, sorry, n over k. It should be n choose k. So like scrape out that fraction line. I don't know how to use Word yet, not to put, how to make a fraction without the line there. Okay, so scrape out that, and I'll show you guys online real quick. There's some reference sheets. So everybody online, this line here should not be there. Okay, so just take it out. So that line there should not be there. It should be n over k. Okay? Does that make sense, everyone?
Yep.
So binomial. So in this case, what is my n value? We'll find the probability. There's 10 questions. Oops. 10 questions, 4 possible answers, 1 being correct. What's my n value? Adam? 10. 10. What is my k value? What's probably getting exactly 4 correct? My k value is 4. Right? Number of successes. I want to have 4 correct. Okay? What's my p value? What's my probability of getting it right? 1 over 4 or 0.25, which would make my 1 minus p, or my failure value here being 3 over 4, or 0.75. Does that make success, everyone? Does that make sense to everyone? Okay, then let's plug in our value here. So what's the probability of getting 4 right? Is our total over our successes. And then we take our probability of success and put it to the total that we want. We want 4 of them right. And then our failure is the rest of the questions. Does that make, we're good with how to set that up? Pereira? Front page, bottom left of your formula sheet. This is the one yesterday we rewrote in our own language. And I left that middle box there if you want to rewrite it in your own language. So if you look at it here, Callum, number of options over how many we want right. Then this is like our success probability. 0.25 is how much our probability of guessing it successfully.
Okay.
So you take your success probability and put to the power of how many you want right. Your failure probability to the power of how many you need to fail. Okay? Which will equal, I'm going to come to you in 1 second, 0.146. Make sure you can get that in your calculator, right? It's great to know the formulas, but unless you can get the answer, the formulas are useless to you. Yep. So 0.146. If you need me to use my calculator to show you how to get it, I understand we're going long this morning, like we're plugging away. So we'll take a good break. Yeah. Does anyone need help in setting it up? Okay. Which one are you doing, Cassandra? C? Yeah. No, A, B, C. Yeah. All right. So.
How did you find that?
Why do all these?
Well, maybe between the 4 of you, right? There's 5 of you in that group. 1 does 0, 1 does 1, 1 does 2, 1 does 3, 1 does 4.
I'll do 4.
You do 4?
0.
0. What are you doing, Mia? 1, 2. Sophie, you want to do 3? Okay. So if we're doing 2, how big's the sample we're taking? 16. How many successes do we want? No. Oh, at least 4. Right? So we're 0, 1, 2, 3, 4, right? So, but you're gonna do number 2. Does that make sense? Yeah. Now, what's the probability they believe in ghosts? What's your success probability? 0.35 to the power of, how many successes do we want? 2. And the probability they don't believe in ghosts, and how many of those do we want? 16 minus 2 is 14.
So you said A is binomial?
Yeah, they're all binomial. Pardon?
Yeah, I got 0.005. Let me try again. I don't know which one of these are right. Do I have to put the brackets on this? This part?
Which part?
Oh, I did.
Does it look like mine?
Because this, no, but I'm saying is when I put it in my calculator, do I need the brackets?
No, you should just be able to go times. Let me see your calculator.
Brackets, I get a different
Let me see your calculator. Do you? You should get the same answer.
No, I got 2 different ones. Like very different.
So 1.0 times 10 to the negative 3, right? 0.001.
Yeah, and the other one I got 0.999. And I didn't put brackets.
Point. I got the same number without brackets.
How?
Press up and look at my formula.
What?
Press like up and you can go scroll back and forth in my formula.
This is when you did it with brackets?
Without brackets. I did mine without brackets.
Did you do it with brackets?
No, but you did it with brackets, so I didn't have to. Try again.
Oh, got it.
Mr.
I
L,
know.
what did you get for A?
The final answer for A is 0.2008.
What are you talking about? You did this with brackets.
No, you didn't.
Yes, you did.
You went too far up. That was yours with brackets.
What is it? The answer is 0.2008.
No, it's still with brackets.
Why did you get that? What did you have to do that? Must be knowledge.
What did you do? Okay, I will do it again. 16 to 0 times 0.35 to the power of 0 times 0.65 to the power of 16.
Yeah, see, but I just
And
put
press
it like
equals.
this.
And press equals.
No, but I just put it in with the 1. But like, I put it in like this. So should I not put it in like that?
No, it should get the same thing.
Well, I didn't. I got 999.
No, you didn't. The time where I watched, the one I went back, you had that written in.
Yeah,
You must have, and you got 0.01.
with brackets.
With brackets, yeah.
Without brackets, I got the 9.
Well, without you didn't because you went 1, because you didn't go 1 minus. The 1 was,
Just always do the 1 minus before.
yeah, yeah. Or you could figure it in your head and put the number in. Yep. The total answer?
Remember, I'm setting up the company to be in such a fun car to drive. Shit's better than you have to know. Just probably that in your life.
B, 0. Pardon? D. Well, they did it the opposite way. 0.9998.
Yeah, that's not what I got.
Okay, what'd you get?
I got 79.95%.
Okay, I'll come look at it.
Because I didn't see normal
Approximation? Okay. So we must not be able to do that. Let me look at that after. Okay, let's jump to, everyone kind of understands that? If not, we can process it in the next little block.
Was it supposed to, was I supposed to be looking for 0, 1, 2, 3, 4? Or was I supposed to be looking for 4 to 16?
At least 4. Oh, damn it. I read that wrong, didn't I?
Because I looked for 4 to 16.
Yeah, it should be 4 to 16.
Yeah.
So when we did 0 through 4, we would have went 1 minus that total. Okay. It should be 4 through 16.
Yeah, that's what I did.
Okay, I'll look at it after with you. Okay. How would we find the expected number of high school students? We would use your expected formula, right? Out of the binomial, which is just n times p. Does that make sense?
I'm trying to do C, no, not what I did.
All right. Probably, would you get? I'll go over it with you deeper.
Okay, I'm just doing like all the same stuff just for each one.
Yep. You need to add them up and then minus it. 1 minus that number.
Okay.
Okay. Do we have another one we want to do, or do you want to go take a break?
We need the longest breaks. We need to
Well,
break for a break.
let's just do. No.
Nah. Showtime.
So should E be the same as our X? Or are E
Pardon?
should E be the same as our
E for that one is n times p. Cassandra, we'll go to the track. When we get back in, Cassandra, let's look at some questions.
Let's
Okay.
go over and reevaluate.